And this is number 3. And specifically, we're talking about part C right now. So hopefully, as everyone was reading this, right? Also, a little side note, I've been updating the textbook a little bit, and pages may have jumped. So you may have noticed that the homework is now, or the problems now are on page 31 instead of regular 30, sorry. They just jumped a page. So if you ever see that, and I mark a page, and I put it in the announcement section, hey, this, just realize that it might be on the next page, that's all. Okay. Number 3, part C, hopefully you realize that it said compound continuously, right? And you either jumped into this form of the equation right away. If not, again, that's okay. What I want you all to realize is that if you listed the details, right, that you said, oh, T is 25. R is, what did I give you? 6 4/5. So that's 0.068. And then you have a P and an F, and hopefully you realize that when they told you a goal of 200,000, you realize that's amount that you plan on having, right? That's going to be at some later date, and that makes you realize that you're solving for P. But if anything, if you don't have your formula sheet in front of you, or if you do and it's not the same one and you have to print out a new one, whatever the case may be, right? The second row of the formula sheet is all compound continuously. And that also means that it's all implied for one-time payments. So remember, one time, no CP. If you set this up correctly, it basically looks like this. So this is what you probably, not you specifically, anyone. This is what a possible trouble you may have run into. And what's happening is, let's see here. If I write it, like this, if your calculator doesn't compensate for it, what happens is that you will get either a number that's way too big or you won't get the proper calculation. And what happens is that it thinks that the exponent in the denominator is not being raised to 0.068 times 25. It will be only the decimal portion, which is 0.068, right? So it might help, even though I wrote it like that, because I know you all visually understand that. We talked about this a while ago, is that maybe you want to rewrite it like this instead, where you go 0.068 times 25, so that you really know that it's contained inside. And then for syntax, just in case if people were thrown off for a moment, it should look like this. It's one single calculation, no multiple parts. Just make sure you use the parentheses correctly. And again, the parentheses only shows up if they provide it here. If they do not provide it, you're going to have to do it. So I just got a couple people applying right now. Point 0.068 times 25 equals, sorry. Okay, so that's what you have there, syntax and all, and you should have gotten the correct answer, whatever it was. Let me pull up the answer key. 36,000-ish, 36,000 and a half. So I'll give that a moment for whoever needs to recheck, redouble take, right? Do this on your calculator if you don't understand it. Just let me know whenever you're ready.
Okay, so I think what I did wrong, which I don't know if other people have done too, is I think I used the wrong formula for this one.
Okay.
The correct syntax,
Right.
which means I possibly could have used the wrong formula for part B.
Part B, remember, and this is for anyone, right? I've already stated for, especially this portion of the class where you guys are doing modeling and whatnot, but even further, whenever you're doing annuities, right? And what happens is that, wait, give me 1 second. Yeah, what you realize that within the modelings, it's really critical, but even more so when we learn annuities for the first time, we notice that if it ever says lease, right? If you see lease, and again, if you don't have this written down on a nice study cheat sheet or whatnot, probably want to start doing that right now and making them the best you can. So if you see lease, the implication is that it's a present value annuity. And you just have to determine at that point whether you're solving for this or this, right? So it's not a regular compound equation where you are only depositing it once. In this particular problem, let me throw up the, no, that's not it. The numbers, where are they? Right here. The numbers so that at least you can see if you have it written correctly. They are the following. RPV equals, what is that? 10,000. I need space here. $10,000.01. 7 divided by 8 again. 875. Minus 1 plus 0.01875. And the other thing you can rely on, unless I tell you otherwise, is not only is it present value annuity, and you're solving for one of those two variables, and the CP will be 12 because you don't pay leases, at least in this world, any other way. So you divide by 12, divide by 12, and we're doing this for 50 years, so that's to the negative 600. Okay, so that's set up for that problem. If anyone needs syntax, just let me know and I'll write it out as well. However, it's nothing physically different, right? It's the same thing where you do the numerator first, hit equals, do the denominator, follow all the parentheses. One common mistake, I was working with someone earlier in the week or over the weekend, and instead of the negative button, they used the minus button for the exponent. Don't do that. Give you a syntax error as well. Now, I give people a moment to take a look at this, whatever they're doing, or whoever's question it applies to, that's fine. Keep in mind though, what other questions you have for number 3 and as well as number 4 as well. Just so that we can keep class moving and not have a pause here. And I need to download this video as well.
When you have the chance for number 4,
Okay.
And for part D specifically, in the model, I don't know where that 0.88 came from. Can we just
Sure thing.
just that?
Yep, absolutely. I'll take care of that. In the meantime, that's going to be our next question if there aren't any more for concerning number 3. So I'll open it up again. What are the questions for number 3? Any parts component-wise, right? That builds your model versus any follow-up questions after the model. Submission.
Explain the overall effect.
Okay. For follow-up question number 2 or number 3?
Number 3.
Okay, sure thing. Homework and all right.
Oh, I'm sorry. Sorry.
No, it's fine.
Sorry.
Go ahead. What was the question again?
Number 2.
Number 2. I'll talk about both of them. Number 2 and number 3 for overall effect. Okay. So if you haven't seen already, I'm assuming as such, the answers, of course, are in the back of the book. But I'll write down the base model here really quick so people can just simply see what's going on. So this is, again, base model here. And I'll write it just for reference. You got this 0.0015 parentheses summation I to 1 and 5 times 3I to the minus 1 minus 2569 and then minus 36,53670. So the first thing I want everyone to notice is, and you can use this strategy when moving forward with any of these problems, especially the models, right? Especially when you see a lot of follow-up questions. Where's this hat? Sorry, my hair is really long right now, and I wear a hat to pull it back. So I'm not gonna start wearing a headband all of a sudden, and I can't find this hat. I know it's amusing. Oh man, it's gone. Who else needs a haircut? I'm in dire need of a haircut. Okay, don't see it. All right. Yeah, I know it's stupid. Okay, so here's the hint that I wanted to bring to your attention if for those that are already unaware. The unique thing about these two right here, 2569 and 36,500, right, is that you have to realize that, again, I wrote it up there, but this is one time. And this is ongoing. That's a good way of saying it. So that means once you go to the second month, right, this has nowhere to go. It doesn't follow through. Right? And then all of a sudden, I got a big red slash here. Boom, doesn't go through. Because it was already taken care of the first month. And then, because the other one is ongoing for this web page, website, whatever I was talking about fictitiously, and it's annuity, you know, it's going to be ongoing. And the expectation is you have to make sure you have it in the next month's model. So how does that help you? Well, if you read number 2, right, I know that the question specifically was asking about, oh, can you talk about the overall increase? And I'm absolutely going to answer that, but I'm just going to give you a little bit extra You should hopefully realize that the only thing that's changing in that question is the summation itself, okay? The only thing that's changing in that question is the summation itself. So what happens is that for the second month's model, you fill out the details that are concerning the summation where the numbers are changing. So of course, remember these details stay the same. Why? Because the whole sigma notation and the 0.0015, I have not told you that you're making money at a different rate. This problem, however, excuse me, is saying that where is it? Growth rate is the same, but first day reaches 7 people. So now I'm gonna draw with a different color now. It goes from 5 to 7, but I told you everything grows the same. So if you look at just this portion, you look at, I'm gonna use a different color. When you look at base model summation versus base model, not base, second month's summation, right? What's the overall effect, right? Hopefully you realize that there's an increase because nothing has changed in terms of growth. It's just how you start or the number of people you started with. So imagine, if you will, you make, I don't know, $100 per person that you see, right? So you're a consultant, you make $100, but then for every person that comes in after the first day, you know, you tack on like another $50 or something because your consulting services are good. It's kind of like tattoo artists. I don't know if any of you guys have tattoos, but I have some buddies that what happens is that they get a tattoo from a really, really good artist. And then the moment the artist becomes famous, either within the community or their work is just renowned, their prices skyrocket. So you get the same kind of quality of work, just all of a sudden at a higher price. So it's the same thing here, right? You start off with $100, you're a great consulting person, and then for every customer that you see thereafter, you increase your price by a little bit. Maybe not $50, but something unnoticeable, like $1, because your rates are just going up. So here you can see that the rate for this particular model, 3 to the power of I minus 1, that's staying the same. It's only your base. Well, you're going to have an increase, right? The overall effect of the model is an increasing. And I may have mentioned this last Friday in the partial lecture and hopefully last Wednesday. If not, I'm going to say it again right now. And it's the fact that if you see more physical people, let me write that here. I'm talking about number of physical people. And what I mean by that is the actual number, so say 1 million people. So the effect from the underlying summation on the base model to the second month, it's an increased effect, right? The effect is grown because of, let me write this in purple, because of an algebraic change, algebraic increase. However, if you see, and I'm gonna switch colors again, one person here, no, sorry. If you see one person here versus 1,000 people here, who's gonna make you more physical money, right? It's obviously the base model summation, right? So that's the difference what I'm telling you there. So you wanna watch out with the phrasing. It may have been confusing when I was presenting it, but the effect, right? The algebraic increase effect is because the numbers are increasing. However, that doesn't discount the fact that if obviously you see more people with the first model summation versus the second one, you're gonna make more physical money. So don't ever confuse effect of the model for actual outcome of your dollar amount. And then last but not least, you still know it's an increase for sure, because this comes through the ongoing payment, but not the one-time payment. So it's just this, right? So you have now 36,500 less of a payment to make again for the second month. It's obviously going to be a positive effect, right? Or an increasing effect for this model representation. Now, what's the actual numbers? Who knows, right? But that's not what I'm asking. I'm asking you what's happening. Is that clear, I hope? For those and concerning about the effect of the model. Because when you go to letter C, I know no one asked it, but I'm just going to address it really quickly. I change both numbers, right? I change, wait, do I change both numbers? I go, reaches two new people. Okay.
You change both numbers.
I change both numbers, thank you. And what's happening is that you can't tell immediately whether which one's better or not, right? But what you can do, and this is just kind of like a cute little trick right here, when you are given, this is just a little sidebar, and don't worry, I won't take a lot of time. Let's do it in pink. Okay, sidebar. The question is this: how do you know when one equation, I'm going to use the word outperforms, 2 words, sorry, outperforms another equation? Right, I was talking to my last section yesterday about this because it was just the way questions came up. Let's say you were looking at stocks, right? And let me see if I can pull something up here. Let's say Apple stock versus, let's look at Amazon, sure, why not? Actually, I'll just do it this way. Let's go for the last month. Then I'm gonna do Amazon stock. And then last month here too. All right. So obviously we don't know what the stock market's going to do, right? But how can you tell between these two, right? If it was an equation when one is outperforming the other, right? I know we're talking about companies and whatnot, but bear with me for a moment that you imagine this green curve that's wiggling up and down is some kind of equation, and same with here. So how would you normally tell? You would look at maybe a single day and you go, okay, April 7th, we're at 259 for Apple. And then you go to April 7th here and you go, oh, I'm at 2000. I know the pictures look the same, but they're scaled differently. So who outperformed who? Amazon stock outperformed Apple stock, right? So you normally would know an equation is quote unquote outperforming or bigger or larger than another one is depending on what value you're looking at. But the thing is that when you look like this, right? See how it says 5 times 3 to the I minus 1, now 7 times 3 to the I minus 1. For part C, by the way, I mean, not part C, for question 3, right, the summation becomes, what is it? Your initial post reaches 10 people and you grow at 2. So it becomes 10 times 2 to the I minus 1, right? You can't compare that. Yeah, 10 is bigger than 7, let alone 5, but does 2 grow as fast? 2 as a base for your exponent, right? Does 2 perform better than 3 at a certain point because your base is higher, right? Now there's a couple of algebra techniques that you can do to rationalize and confirm the answer, but the easiest way to answer this question is just graph it, right? So now I'm gonna go back to Google right here, and I'm gonna open a random Google page. And then I'm going to show you that you can, if you didn't already know, you can graph onto here, right? So you just go y equals, let's go with our original one, 5 times 3 raised to the, so I wrote I, but here just put x minus 1. And it will show you your, of course, exponential growth. So you can see it right there. See, there it is. Not a big deal. And then if you put a comma and write the same exact equation, and then just adjust the 5 for a 7, you're going to see Google be able to graph both of them, right? So you can see right now that at any point in time, you can see the 7 graph, base 7, right? The number of days you started with, in other words, AKA the red line, it's going to be more don't want to zoom. How come I can't do this? Oh, I got to move 2 fingers, I think. Oh, come on. But anyway, you can see that the red line will outperform the blue line because it's always on top, right? No matter which value you pick, the red is going to be higher than the blue. Why is that? 7's bigger than 5, even though they're growing at the same rate. So now, last but not least, if you throw in the same exact thing, but you adjust for 10 and 2, times 2. So now we're going to see 3 colored lines. And you can see now that both red and blue outperform, what is that, orange, it looks like? Or some kind of bright yellow. But the real question is what happens when you get, zoom out vertically. What happens when you get further up? Oops. Right, you want to go high in such a way that when you go up, obviously it's going to be easier than on a computer. See, the number gets high, but it's a matter of who always stays on top based on the x value. Why is this x value negative right now? Right, at x equals 8, you're at y equals a really high number for blue. And then if you do the same exact thing for yellow, in the same region, you can see the numbers, how they approximate. Now, obviously, I'm not asking anyone to do this on their final, let alone doing this in class or even doing this at home or anything of that nature. It's just more of a realizing of, hey, how does this work when I'm asking this type of question? So if you don't know the number and you don't want to take the time to calculate these numbers by hand, right? Who wants to do that? You can graph it. And that's how you can tell when one has an overall versus the other. So if you notice that in my answer key for the third question in particular, I do address that, hey, you do, and you're allowed to say this too. You do notice that you start off with a higher base of 10 instead of 7 for the third month. But the thing is that since the exponential growth is now slower, it's ambiguous as to say definitively whether one will be higher than the other. At one point, one will be higher than the other, but can you say that it's going to happen for the entire duration of the time, right? That means from day 1 all the way to day, say 100, will one equation or one model outperform the entire time? And most of the time, you'll find out that it's no. They'll say, hey, at one point, one is going to be on top of the other, but then if you go so many days out, they'll flip positions because of the way the model is structured. So hopefully that makes a little bit more sense there. What other questions for number 3? I didn't forget number 4, so don't worry. I remember what question we were going to discuss too. It's the 0.88 in front of the profit function. So there's that. All right. So number 4, assuming that people have the base model down, let me pull up the solution so I could just copy it here. Base model is the following. I wrote it in symbols first, just because there's a lot of information. Profit function for the lease, the recurring payment, for the deposits, the other recurring payment. And I said you're going to be taking 12% of the profit function, and then you'll be paying your employees. So if you take the time to fill out the numbers, it's going to look like this. What is this? 29.933x. By the way, your answers, of course, will vary if you use 0.93 or 933 or 9333, depending on what you're doing. And that's the reason that when we talk about final format, I have to address how I'm going to uh, 29. How I'm going to go about grading and all that fun stuff. All right, cool. What do I want to address? I want to address that if you got the model just like this, and then you took the time to distribute not 0.12, but negative 0.12 to here and here, and then you rewrote your model and you do all the questions I asked, you'll be 100% correct, right? It may look a little choppy, but that's the only distribution that exists in the problem. If you write it at face value, you got profit function, line up with profit, lease with lease, deposit with deposit, and then now 12% of the profit function, or 0.12. Now the 0.88 is not mandatory. It's just those that have stronger algebra skills. I just wanted to also lay out that if you write it like this and distribute what I have circled in light blue right there, you're still gonna arrive at the right answer with you assuming no mistakes. And if you round properly, X, Y, Z, A, B, C type of thing, okay? Now, where does the 0.88 come from? The easiest way to think of it is that this piece right here, AKA the profit function, is the same as this, is it not? The answer is yes. Well, what's the number that's in front of the first profit function? An invisible 1. What number is in front of this profit function here? Negative 0.12. Well, it's kind of like variable subtracting, right? So if you have one whole p of x here and you got 0.12 p of x's and you subtract them, what do you have? How many p of x's do you have in total? You now have 0.88 times 29.933x minus 100. And of course, these two stay the same in black because they're just numbers. And then that last term disappears. Now, do you have to do it this way? Far from it. That's why I had to acknowledge first and foremost that if you distribute that and you do everything correctly, then it just works the same. This is just an easier way because it's less things you have to physically calculate because you realize that, oh, the profit functions are the same and just subtracting how much of the profit function you have left, right? If you were present for Friday's class, remember how I said that I made $22.05 an hour, but then I added taxes to mimic federal or national taxation and state taxation. So I make a certain amount, and then the state specifically, if you hear someone say, oh yeah, I make 75K before or after taxes, it's like, oh, that's the number before taxation. So then you don't really make 75K, you make maybe 75% of 75K. Well, where did 75 or 0.75 came from? If I add up all the taxations I have to divvy out to, it becomes whatever the number is. So if you get taxed 10% from state and 15% from federal, and then all of a sudden you add those together, you know, that's 25%. So then instead of saying 75K is what I make, you say I make 0.75 of 75K or 75% of 75K. And again, if you do the math and everything for the break even and the rest of the problems, it'll be correct. So it's just a matter of personal preference, right? What are the questions for number 4?
Can you go over part C? Like the syntax?
Part C, oh, syntax? Okay, sure thing. What kind of problem was part C? Part C was, monthly deposits. Okay, so part C, so this is where the 0.88 comes from. This is the question here. Just put that there. Now specific to the problem itself, part C if you're worried about syntax, let me write out, where the hell did it go? Oh, there it is. Let me, you know what, let me write out just at least the setup for the formula. 10 million, 0.0612, 1 plus 0.0612 minus 1 over 12 over 12. How long do we do this for? 40 years, so that should be 480. Okay, so that's that. Now, here comes syntax. Syntax is the following. We got 2 steps, right? It is step 1, 10 million times 0.0612 divide, actually, you know, I should do that in green still compound period specific, 12 equal sign, and there you go. Without clearing the calculator, right? You go divide sign, double parentheses, because you see there's double parentheses there written in the formula, so you just mimic it. 1 plus 0.0612 divide by compounding period, close the parentheses, caret, 480. Nope, that's supposed to be in green. 480 minus 1, close parentheses, equal sign. And you should get the right answer though.
Professor,
Go ahead.
can you go over the break-even question?
Which part about it exactly? So you take this base model that I have written up here, right? And for whoever asked the syntax, just let me know if I'm scrolling too far, too quickly, if you still need it.
No, I got it. Thanks.
Okay, perfect. So the break even, you just look at the base model again.
Yeah.
You're setting this equal to $0, and you just solve for the x's. So my follow-up question to you is, what about that do you feel that went astray? Sorry, because this, and this are okay. So it's just a matter of, did you distribute the negative 0.12 or did you use the 0.88 method?
I think I distributed the lease and deposit wrong, actually.
So my question then is, are these numbers, if you're looking at your homework, were these numbers correct, at least one and
yes.
Nope. So these are good.
Yeah.
All right, cool. So you add those 2 numbers together, and then
that's what I did.
And then did you, on the far right side right here, that the light blue, did you distribute like this? Did you make sure?
Oh, so, okay. See, that's what I was missing. I didn't put that into the equation.
Right. So here's another thing that students were doing as well. When we're looking at a model, this isn't just so I didn't recognize whose voice that was.
It's
If
Maeve.
we're looking at, oh, Maeve, perfect. If you're like Maeve and you're kind of like, hey, what's going on here, right? The number one mistake students make is that when I ask for break even, they shut down and they only do it for the profit function. And that is totally incorrect for this problem, because why?
Okay.
We're looking for the break even point for the entire model. Why would you only show it for the profit function? Because then that means you're breaking even for just the profit function, not your entire expense line.
I see.
So that's one way to go about it. The other way is just to remember, I know you're about to say something, Maeve, but let me just show this really quick. Okay. If you didn't combine the profit functions to get the 0.88 and then distribute, the big thing that students make a mistake here is that they distribute correctly. I forgot what these numbers are already. Let me write them down really quick. 29.933 times 0.12. They remember that there is a negative here, 59196x. So they do this correctly, but then they forget that when they distribute the negative 0.12 to the y-intercept, it becomes a plus 12, and that plus sign throws people off as well. Okay, so now your question, your follow-up question.
I think what threw me off in terms of my thinking for this
Sure.
problem was that the like percent that you're giving your employees was like had its own little question. So I thought that that was separate. I like completely forgot that it was an expense.
Ah, I see. Okay, yeah.
Yeah.
So then for here moving forward, if at any point, not just Maeve, of course, it's just her question, if any of you are reading the component portions, right, I can tell you right now, it will go in the model, right?
Okay.
If there is a separate calculation, it will be something like we don't have any particular examples going over today, but if you just happen to be in front of a computer, any of you, or you're doing the Zoom over your phone and you're looking at a video, I'm sorry, you're doing the Zoom over the phone, but you're looking at your computer, or you're doing, whatever, vice versa. If you go to, where to go? Oh, here we go. If you go to my Google Doc and you go to the lecture that says, where the hell is it? 1/10 of your income, team weddings in a day, but you're borrowing 70%. Social media division. Okay, there you go. It's well, it's actually the last page. So it's the one labeled lecture MM03, but it's the 4th page. So if you happen to be looking at that, and if you're not, you can just either listen to me or tune me out. But just specific to this is that if you look at that problem, all 3 white bullets, 1, 2, 3, you got 3 bullets, you got calculations, but they all contribute to the model, right? I'm not going to give any of you, let alone future students, some blank space just because to have you test it and go, oh wait, but this doesn't go in the model, unless I specify otherwise, and I haven't, and I don't think, nor do I foresee myself doing that. But the closest thing where you may have a question that's being asked, but it doesn't go directly into the model, is that if you look at after the leading question, aka make your model, and you look at the 3rd question, right? It says, suppose for the 2nd month, you want to take 15% of your income to deposit once into a mutual fund, but you have 2 options. And then I asked you, which account should be used? What is the 2nd month's model? You should realize that the first question asking what account should be used is a comparison account, and you're using the effective interest rate. When I ask for the 2nd month's model, you don't know what the actual calculation would be because I didn't tell you how long we're depositing for, right? And what the goal is. But I still give you that 15% of your income so that when you build it into the model, despite not knowing what the actual number is, you still have a formal representation of it. Tying back to this, yeah, I say, hey, 12% of your income goes to your employees. And you don't have to even distribute it out like in light blue that I have right there on the far right side. That looks like a plus or minus symbol. Sorry, that's supposed to be just plus, right? But you know for a fact that that has to be included in the model. So again, the primary statement is that I'm not gonna have you work on a component that does not go into your model. So if you remember that, you'll just be good. You just double check, hey, I got A, B, C, D, E, F, G. I better have A, B, C, D, E, F, G in my model. And again, unless it states otherwise. One example where it states where it's not included in every model is, say, those stipend examples where I go, hey, you're paid a stipend and it's only going to be deposited once every other month at $1,000. So that means for month 1, there better be 1,000. For month 2, there better not be 1,000. But for month 3, there better be 1,000 again. So there'll be very explicit examples if I do something wacky-eye, if you will. A little bit clearer now, Maeve? Or anyone for that matter?
Sorry, I was on mute. Yes.
No, that's fine.
Yes, much better.
All right, perfect. What other questions for anyone, opening it up again for number 4, if any? Always like to do a long, awkward pause there. All right, cool. So what that means now is we're going to talk about final format. So as I mentioned earlier, if you trickled in, that's fine, no worries. You didn't miss anything super critical. But what I will say, where the heck is it? Section. This is the last lecture. All right, cool. What I will say is that I don't ever give extra credit. I'm not going to start doing it right now on exams, but what I will do is I'm considering giving another homework assignment, homework number 8, but it'll be purely optional, right? It'll just be extra credit and whatnot. So I'll just type it out. Okay, so first thing is note. Thinking of providing homework number 8 strictly as extra credit, but looking for correctness as well. So I'm actually going to grade this homework as well, make you work for it. Okay. Now for the final exam format, you're going to be looking at something like this. Okay. I've come to the conclusion that it will be a combination of Blackboard entry and uploading answers like you did for the last 2 homeworks, right? Because I'm sure as most of you saw in the feedback notes that I said, hey, had to adjust this and had to give points back and all this fun stuff. And since the answers were already opened after submission for both my sections, it's nice because what will happen is that it allows you to see what the answer was, and you can also see how the credit was given back to you, right, as well. Not individually questions, but you can see as a whole, like, oh, I gave you this many points out of it. So there will be a combo of Blackboard entry, so that's type in answers, and uploading images of problems. Okay, and the other thing is that we'll talk about this in a moment, but that means that I have to make the exam longer because I don't want people to go, oh, I was approaching the deadline of the time frame and I couldn't do it because I couldn't upload because the internet was not working, something was not working. Something always doesn't work, right? When it rains, it pours, or Murphy's Law, that type of thing. So what that means is that I'll talk about that in terms of addressing time for a second, but I want to say that this is open book, right? Can't trust you to not look at your notes, but definitely working solo. Can't trust you to work solo either, but here's to integrity and whatnot. Now, in terms of timing, this is what I want to address. So I'm going to do a little subsection here. Okay, this will be in a single sitting, done in a single sitting. However, you can go back and forth with questions, right? You can backtrack. Okay, I'm going to give extended time for this. So again, my rationale is that if we're in class, you get 2 hours, that's it, right? If it's a proper take-home exam where I gave it out in class and then you guys come back to me in a week and then give me handwritten things, I would give you a week because that's what we did in grad school. We're in a unique situation where you get to do it at home, you don't do it in class, but I can't give you the full range of a week because I don't want to stare at the computer for 25 students and then 2 sections of that, and then, you know, however many problems, multiply that and just stare at your papers all day. And I'm definitely not going to start asking people to start mailing their exams to an address. So obviously there's going to be some reasoning. So it will be extended time to compensate, compensate any type of difficulties. What kind? We're talking about tech, breaks, etc. Right? Maybe you need to take a break or whatever the case might be. So that means that I'm probably going to give about 4 to 5 hours. But then if we do that, you can't take it on Wednesday or Friday if you have a class that comes after. So someone addressed that in my other section. They're like, hey, I love to take advantage of this extra time, but I have another class. And I was like, oh, right. So how do we do that? Well, the nice thing is that since this class meets on a Friday, a majority of you, except for a handful of you, I don't remember who exactly, of course, but definitely know that there's a handful of you that have an 11 a.m. class on Friday. So if your professors are meeting all the way until then, obviously we'll figure something out. But for the rest of you, you can obviously do this at any time on Friday, right? That's one example. Another example is that for our class specifically, Friday is a good exam date, or the weekend, right? So block out time on the weekend or Friday, depending on your classes or whatnot, and just do it. But basically, also, depending on how your finals are going to be administered, right? What will happen is that you're going to find out for sure whether one day we'll have something or not, right? So what will happen is that even though you're supposed to be doing it in a single sitting, what we'll do is we'll figure out when it comes closer to finals, and I'll go, hey, can everyone do this date? And so the expectation is everyone will be sitting down and doing it at that time, right? Or everyone will be sitting down and doing it at another time. Maybe I'll do it in a window between 48 hours, right? So between 2 days, you can sit down and do this 4 to 5 hour work. It's just I don't want a lot of variance where people have like a huge week to do it and they can pick any day, and then I have exams coming in anytime at any point, and then that leaves open and ambiguity as to people submitting things, right? If it's a certain time, I know everyone's supposed to be submitting it, I know everyone's supposed to be working on it, and then that's that. Okay, so that's that, or the weekend. So that's done in a single sitting. Go back and forth questions, extended time, compensating type difficulties. Friday is a good exam date after a certain time, or the weekend. Okay, so that's everything I'm pretty sure that I acknowledge in terms of technicality, right? Even if we had if this was an regular online class, you realize that you had friends, peers, classmates, whoever, that when you take an FIT online class, right, the expectation is that you come in to take a final in person. So, you know, it's just things like that. Now the actual content of the exam itself, right? We're going to have 6 to 7 questions. And more than likely, we're going to also skip one. Oops, not slip one, skip one question. Just like the first exam. Not the second exam because it was really short, right? And then what we're going to do is we're going to have 2 questions from the first exam. Okay, and I can already tell you though, specific to the first exam, there's going to be no graphing and no simple interest. Too basic, right? Now again, because I hung on to your first exam questions too long, again, I apologize for that. If you want to know what you got on them, I can just take pictures and email them or send them via Remind. But I also already have the first exam posted on Blackboard, so you can just print them out. I'm sorry, not print them out. You can download them and then work off of them and everything of that nature, okay? For the second exam, you'll have 2 from the second exam. And there is definitely no purchasing analysis there, which leaves you with basically annuities and the, what do you call it, amortization schedule. But again, that's nothing new that you've been doing. And last but not least, there'll be 2 modeling problems. So as you can see with this format, when you have 2, 2, and 2, and I tell you to skip one, there'll definitely be no more than 2 modeling problems. I said 6 to 7 because I might throw in another question from the first or second exam. However, with 2 modeling problems, you can see that students obviously skip, for the most part, one or the other modeling. But that doesn't mean that I have not seen exams where students, they totally tanked in remembering either first or second exam content because the way they studied, and they ended up doing both modeling problems. So that's not unorthodox as well. So when I say, hey, there's a combo of, where is it, typing in and uploading, right? Obviously the modeling problems are going to be uploaded based. But then the other questions, right, I'm going to try to, well, not even try, I'm going to really lay it out thick so that you have the correct questions that help you lead to the correct answer. And remember, I did this, you don't have to write this down, but I was working with a student, and what happens is that, say you had a question that was something like this, right? Where I go, okay, just sidebar, right? If you have a question that says, what percent money tripled in 20 years, compound daily, right? And then you realize that it's compound daily. You're looking for what percent. So you know that the compound is 365. You know, since it's what percent, you're using this formula. By 1 over n. There we go. Using that formula, right? And then you can make up numbers so that your P is, say, 100. If you tripled it, your F is 300. You're looking for I, and your N is 20. So remember this part right here where you did 20 times CP or 20 times 365, right? When I say enter the values, I'm not asking you to enter 20. That's too easy. I already told you it's 20. Why would you have you type 20 here? The way we do it, use a different color. The way we must calculate properly is that it's 20 times the CP. Don't omit the CP. Another example is that when people start doing calculations and they move to this calculation, all of a sudden they drop the CP. If you take the time, in this case 20 years, to multiply by the compounding period, why would all of a sudden you go to the equation and you drop the compounding period, right? Don't do that. Or another common mistake students do is that they write the equation down with the time, in this case 20 years, times the CP, and then when they move it up here where the pink arrow is, they multiply by the CP again, because they go, oh yeah, I gotta multiply the compounding period. Don't blindly follow rules, right? Make sure that you follow the rule and give me the correct details that I want. This is more pertaining to the second exam, right? And then don't overestimate or overthink or overanalyze where you do this. So I would still suggest that as you're doing this, you're studying, right? You should make a cheat sheet, a cheat sheet, right? A proper piece of paper that you're gonna have with you that has the majority of questions that you feel like you struggle. And what you don't know is that for the first and second exam, remember how you made that note card? See, that was helpful. On the final, I always give a full sheet of paper. So
that gives people plenty of real estate to go at it, attack, whatever you want to call it, right? So you should be working on a cheat sheet as well so that you can watch out for these pitfalls that students normally have. And the instructions, for example, I said, hey, provide the values as if you were to plug it into the equation. You never plug into the equation with the time without multiplying by the compounding period, or the interest rate without dividing by the compounding period, you know? So it's supposed to be easy, but don't get carelessly easy, right? It's not like, oh, here's variables, list the numbers. It's like, yeah, list the numbers, but how you're supposed to use them, right? It's not 20 for 20, 3 to 3, 5 to 5, 6 to 6. You know, that's like a matching game. This is not a matching game, right? This is to help you flow out your ideas on Blackboard so that when you physically write it on paper, it comes out easily, right? No one, and I'm saying no one, should be taking this exam with their calculator and not writing a single thing down, even for the quote unquote easy questions, right? That's how mistakes happen. So that's just my suggestion about it. And I had to say the same thing for my other class too, because again, most of your answers, I saw that there are people that were right on top of it, and then there are people that made mistakes that they would never make those kind of mistakes if it was a written exam, because they got careless or they got lazy a little bit. All right.
I have a question.
Sorry, go ahead.
Should we write it out as 20 times CP or 20 times 20, or should we solve it and write it as 40?
You can be, well, first of all, you're multiplied by 365, right? Not 20 times 20. Just wanted to make sure there.
Oh, yeah,
right?
sorry. Yeah.
Okay, cool. I was about to freak out there. So what you want to do is, the nice thing about Blackboard is that it allows for multiple answers. So if you gave me 20 times CP, 20 times 365, or whatever that number is, let me just humor myself and do this so that you guys can have an extra practice problem, 7,300. Right, if you give me any of those three answers, they'll be correct. And then I'll also write it where it's, 20 times CP, I might give an answer to where you have to put the little multiplication sign, or 20 asterisk CP. Yeah, I'll make sure that all these formats are available so that Blackboard will recognize any of them and it'll be correct. So don't worry about that. Those things are easy, because I'm pretty sure if you talk amongst each other, there's some people that said, hey, I did 20 times CP, and then someone said, well, I wrote down 7,300. It's like, oh, well, both were marked correctly, depending on what it was. So don't worry. Those kind of details I'm already aware of, because when I was making the first Blackboard exam, it gave me those kind of options. So don't sweat that.
Okay, cool.
Mm-hmm. What other questions in terms of format here specifically? Because there were just two more ideas or details I wanted to not even discuss, but let you know, and then we're good for the day.
Just
of course. Sorry, go ahead. No, that was my fault.
I noticed that you wrote Friday is a good exam date, but is it this Friday or the upcoming?
No. It would be the latest. It would be, we still have 3 more Fridays. This Friday, well, technically 2 more Fridays, right? This Friday, I'm just going to hold class for answering questions. And then the next 2 weeks will basically be, review. But that's actually going to lead to my next point. But no, the exam is not this weekend. I have nothing written for you guys. So I have the previous exam, final exam for an in-class one, but I have to adjust it and all that kind of crap. But yeah, nothing this weekend, so don't worry.
And there won't be like a sample, right? Like, or will there be like of how you did for the other exams in your textbook?
Right, so that's the perfect thing. So I'm going to lead into it right now. So what's going to happen moving forward? I said it's a few of you at the beginning of class. So normally when we have a class like this, right, we're in person, I go, hey, what other questions are there? And it's already 10:14. If I don't hear anything, I'm going to go like, cool, well, I have nothing else for you. And that's all I have for the day. So of course the implied sense there is that well, get the heck out of here, right? You got nothing else for me. I got nothing else for you. Obviously, you can't do that all the time, because then you get people going, oh, well, Professor Law cancels class all the time. He lets us out early. I feel like I'm not getting, my money's worth, or whatever the critique is. And that's fine. I understand that, right? It's just that in the past, when I've had feedback like that, it always killed me, not in a bad way, it just killed me in an amusing way, is that, oh, he cancels class too much. He let the class out too much, but it's for a class that's not your major. This is not a major. It's not even well, no, it is a minor, but it's only a minor for a handful of people of all the years. So I just find it ridiculously amusing that for a major core class that people can be so uppity about it. When I was taking sociology or philosophy and this class was canceled, I was like, hell yeah, man, I don't care. It's a general ed course. I'm a math major. I don't care about this, And I imagine that people take it that way too, but they don't, which is so strange. FIT population is so weird. So now that we're online and I'm not taking anybody's precious time in terms of commuting or making them, go an hour or something crazy like that out of the way to come for a 9 a.m. class and go, okay, I'm done in 45 minutes and then bounce and then that's it. There's less reason for people to be ticked off for that. So moving forward, if I go, cool, what questions do you have? And nobody brings questions, we're done, right? We're not a remediation class where it's like, well, let me give you this question so you can, nah, man. You guys all have the practice problems. You have my textbook, you have practice homework, you have examples from lectures. It's all here, right, in terms of details. So what about practice problems? Now, if you go to my appendix section and you go, there is a sample final problem, but I constructed it in a unique way. And it's on page, hold on. It says sample final exam, but it may not be so blatant. It's on page 43 as of right now. Right, so I'll say page 43, sample final. If you go there, I have, what is that, 1? And not only do I have the answers, I have the solutions all written out too. So I have 1, 2, 3, 4 problems there. But the unique thing is that they're all modeling problems. And you're going like, but the whole exam isn't modeling. And I go, I know, but the whole exam is made up of a model. So obviously I'm not going to start it on a class that is online that all of a sudden transition online. But if I had it my way, I would try to start training students to do exams that are literally only 2 problems, but they have huge follow-up questions so that they can get in the model-esque sense. So what happens is that if you start doing these problems on page 43, they're going to mimic models, but you're going to find way more details that involve concepts from the previous months. For example, effective interest rate, right? We don't talk a lot about that. They're in the model so far, but I have an example like that. Or amortization schedule, right? You guys did that very well, but I'm bringing it back in. Cost, revenue, profit, we've already seen that a million times already, right? So that's already built into the model as well as on your first exam. And then all the other details that we've been missing is the annuities, the finance equations, but in the model sense, you've been solving it for the same variables, common times, right? The recurring payment, the present, the recurring payment, the principal, the recurring payment, blah, 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 this and that. So then that means that between the first and second exam, the only thing you got to watch out for is when you solve for the other variables that you normally don't see on a model, right? Like how much time, what percentage, what interest rate, things like that. So that's why with this sample final, yeah, it's a little bit trickier in the sense I made it in the modeling sense, but you have all the answers there, right? Not only the answers, but the solutions all written out. It's all been double checked already, and I've already used it several times. So there's that. You might see like a trailing question that may ask you to graph, but that was me just trying to be complete in terms of comprehensive for the class, right? So there's that. So there's plenty of practice, which also means that from here moving forward, short of that like extra credit homework, which I'm not going to write answers because it's extra credit, that's why it's extra credit. We'll address that too, but that means that moving forward, you guys are gonna come and bring the questions to me, right? Obviously, you're not going to do this sample final right after class ends, But start working on a couple of things. Start looking back at your first exam, right? Re-download the file to your thing, have your piece of paper out, and start doing the problems. And then my expectation of you is just come to class with questions. And if there are any questions, we're done for the day.